Alright guys, today we're going to look at finding the area under curves, and we have to use trapezium to do that. And so we're going to start by finding the area of this trapezium. Now you hopefully will remember, but if you've forgotten, the best way to work out how to find the area of a trapezium is to take a copy of it, like this. We're going to flip it around and attach it onto here. And so hopefully you can see that this length on the bottom is 4, this is 6, and this is 3. So in total what we had to do is we do the 6 plus 4. To get this is 10, and so it just becomes 3 times 10 equals 30, but then because we only want one of those, we divide it by 2. So half times 30 equals 15. Okay, that looks pretty rubbish, sorry about that. So half of 30 is 15, you should be able to see. And then so a general formula for area of a trapezium, if we take one of these here, and if I just call this A, this B, and this the height. So what we do is we first of all did the 6 plus 4, so we're going to add that up. So we've got the A plus B, and then we times that by the 3, so times that by the height, and then obviously just halved it all. So the area of a trapezium is a half, you do the A plus B, and then times by the height. If you've forgotten how to do that, go back, have a look on My Maths. Here we've got a graph. This is showing a car's speed versus its time, and the bit we're focused on, so the exam questions you might get, is working out the distance this car has travelled in the first 3 seconds that it's been moving. And to see that up to 3 seconds it's been moving up here at 18 meters per second. So along here we should be able to see that this one here after 3 seconds, here, is over at about 18 meters per second. And so we want to work out the distance, and to find the distance from a speed time graph we basically want to find the area underneath it. So it's the area between 0 and 3 seconds underneath this curve here. And to do that, there's a way in A level called integration, but an easier way to do it is to split it up into different trapeziums. Okay, so back here what we're going to do is a nice sensible amount seems to be each 1 second block, and so I'll show you what we're going to do. And so we're going to first of all take this little trapezium here, which actually looks a bit more like a triangle, that's fine, and then we're going to go from there up to the next 1 second, and so we're going to make these little blocks here, and you can see that's a pretty good estimate. It's a pretty good estimate. So we've got 3 trapeziums, there's a small little area in here which isn't quite covered, and a small little area here. This one here is even smaller, so it's a pretty good estimate for the area under the curve. And so to do that we need to work out just the areas of each of these blocks here. And so this first one here is very simply going to be half times, and then we've got 0 for this side, plus 2 times by the height, and this time the height of each of these, if you imagine them on their side, the height is going to be 1 for each one. So that one is just going to end up being 1. This one here we end up with a half, and this time it's going to be, this length here is 2, this length here is 8, and so we have 2 plus 8 times by the height, which is 1, which ends up giving us 5. And this final one over here, we've still got height of 8 here, this one here is going to be 18, and so we end up with a half. I'll do this in blue to keep it separate. We end up with a half, and this time it's going to be 8 plus 18, and this time our height is 1, and that gives us 13. And then to find the total area, all we have to do is add all those up together. So we end up with 1 plus 5 plus 13, which is 19 meters. And so your answer is going to be 19 meters travelled. The area under that curve is pretty much 19 meters. And that's how we find the area under the curve.